Hi guys, in this video I'm going to go through how to sketch trig functions. So we're going to start off with some theory and then I'm going to get into some actual examples of sketching trig functions without a calculator. So first things first, we need to know the two basic trig functions, which are y equals sine x and y equals cos x, which are on the screen here. Now the general form of any trig function is this. Notice we've got a, b, c and d. So a is always the amplitude, and the amplitude is the distance from the x-axis up to the peak. So you can think of it as half of the range of the function. Then we've got the frequency, which basically just change how frequent our graph repeats itself in a short amount of time. So b is equal to 2 pi over the period being t. And with a regular trig function like y equals sine x or y equals cos x, the period is always 2 pi, hence 2 pi divided by 2 pi would just be 1. C is our horizontal shift, which shifts the graph left or right, and it's the opposite to the sign in front of C. So if it was x minus pi on 6, then we would shift our graph pi on 6 in the positive direction, and vice versa. If it was plus pi on 6, then we'd shift our graph to the left. Then the d value is the vertical shift of the graph, and that just shifts the graph up or down, and it's not opposite to the sign. So on that note, if we think of y equals sine x here, we can write this a little bit differently. We could write it as y equals 1 times by sine bracket 1 bracket x minus 0 bracket plus 0. So notice I've written it as general form, and that's because this has an amplitude of 1, right? So a is 1. The b value is just 1 as well, because it's going to be 2 pi divided by 2 pi. And there's no phase shift, there's no horizontal shift, so c is 0. And there's no vertical shift, so d is 0. So even though y equals sine x is a basic function, that's kind of what's going on in the background. Now, just before we go through some examples, let's unpack a very important idea. And this is something that I don't think is emphasized enough when it comes to sketching trig functions. All trig functions can be split into quarters. So what I mean by that is this graph here of y equals sine x. Notice there's the first quarter is where it peaks, the second quarter it cuts through the x-axis, the third quarter is where it has its lowest point, its minimum point, and then the fourth quarter we're back to normal, and then this graph would continue to repeat itself in a similar pattern forever. So the significance of this quarter idea will become clear shortly. Okay, so let's get into sketching a trig function. We'll start with one that's a little bit easier. So this is our function we've got to sketch. I can already see that the amplitude is 4, the b value is 2, and we've got a vertical shift of 1. So the whole graph is going to be shift up 1 unit. So step 1, whenever sketching these, I just draw a blank Cartesian plane, but not a Cartesian plane with 4 quadrants. I draw my Cartesian plane like this. And because we've had a vertical shift, I'm going to draw a dashed line at y equals 1. So I'm imagining I'm shifting my whole graph up 1 unit. And we can think of this as the new x-axis in a way. Now we're going to draw a sine wave or a sine function, but just ignoring the quarters for now. We're just going to draw a sine function as if the line of y equals 1, that dashed line, we're going to pretend that's our new x-axis. So we've drawn that. It's obviously not to scale. Step 4, we're going to label the max and min points on the y-axis, and this is based on the amplitude. So because the amplitude was 4 units, if we go up 4 from 1, we're going to get 5, right? So the top y value is going to be 5, and then if we do 1 take away 4, the bottom y value is going to be -3. So this graph ranges between -3 and 5. Now that we've done that, so nothing really too complicated so far, right? Now we're going to determine the value of each quarter by finding the period. So the b value in this case was 2. So to find the period, it's 2 pi over b. That formula is always true. So 2 pi divided by 2, the 2's are going to cancel, and therefore we get the period is going to be equal to pi. So what that means, if one whole period is pi, then that means that each quarter is pi on 4. I've just divided pi by 4. So now what I'm going to do is I'm just going to label in each of my quarters on this graph. I could have also put those blue lines on the x-axis. Either way is cool. And notice the first quarter would be pi on 4. Then the next one is, well, half of pi is pi on 2. So we've got 1 pi on 4, 2 pi on 4. The third one there is going to be 3 pi on 4. And then pi is technically 4 pi on 4, but we would just write that as pi. So now we're finished, right? We've sketched our trig function. We could go and calculate the x-intercepts, but to be honest, it's a pretty complicated process and it's not necessary in most cases. It barely comes up. However, I will still do a video on how to find x-intercepts if you're in a tech-free exam. In tech active, it's super easy. You just type the graph into your function and you just find the x-intercepts that way. All right, so next function, we've got y equals 3 cos 4x minus pi on 2 and then minus 2. Now notice this isn't in general form just yet, right? Remember, general form is this form here. Notice there's kind of brackets inside of brackets. So what we have to do first, and this trips up a lot of students, is I've got to factorize out 4 from inside of the brackets so that I've got brackets inside of brackets, which I've went and gone and done here. So step 1, if you don't have a trig function in general form, you've got to factorize the inside of the brackets to get general form. Now I can clearly see my b value is 4 and my c value is going to be pi on 8. And there you go, you've got A, B, C, and D, right? So we know our amplitude is 2, our vertical shift is -2, etc. So step 2, we're just going to consider the horizontal and vertical shift for the new axes. It's not really the new axis, but that's how I like to think of it. So notice I've just labeled a dashed line for y equals -2 and for x equals pi on 8. And that's kind of like our new x and y axis in a sense. Step 3, now we're going to draw the graph and we're going to label the maximum and minimum values using the amplitude. So I'm just going to draw it normally. A cos graph looks like this. It starts at the top, it starts at 1 normally, and then it has kind of like a U shape and it comes back to 1. This is obviously not to scale again. And I've got a 1 here for my top value. The reason for that is because my amplitude was 3, right? And my midline is now -2. -2 plus 3 is 1, right? So 1 is going to be my top point and -5 is going to be my bottom point. Now we've got to use B to calculate the period and the quarters, which are going to be always important when sketching a trig function. So the period we can see is going to be 2 pi on 4, right? Because our b value was 4, which is pi on 2. So that means that each quarter is going to be whatever pi on 2 times a quarter is, right? Which turns out to be pi on 8. So every single quarter on this graph goes up in pi on 8. It is a little bit of a coincidence here that this is the same value as our phase shift. That's not always the case. So it's very important to note that due to the phase shift, right, each quarter must be added to pi on 8. So each quarter must be next added to the phase shift. So the first quarter is just going to be pi on 8 plus pi on 8, which is 2 pi on 8. Now, if our quarters was not pi on 8, let's say it was like pi on 4, then we just have to do an extra step here because we'd have to make sure the denominators of the fractions are the same before we add them. In this case, we've gotten really lucky. Pi on 8 plus pi on 8 is just going to be 2 pi on 8. Then we repeat the same process for the second quarter, right? So 2 pi on 8 plus pi on 8 is going to be 3 pi on 8. And I'm not going to worry about simplifying the first quarter here to pi on 4. I'm just going to leave all of these as being over 8. The same thing for the third quarter, and then same thing for the fourth quarter. So that's our final graph of the original function. And note, in another video, I'll show you how to calculate the x-intercepts, tech-free, but it's an absolute mission, honestly, and it barely comes up in exams because it is a huge time killer. So teachers normally don't put it in exams, but I will show you how to calculate the x-intercept of a complicated type of function like this in another video. If it comes up in a tech active, so if this whole video, in my opinion, is pointless in a tech active case. If you get any trig function and you've got to sketch it in a tech active exam, unless your teacher or your school has specifically stated that they want you to show some sort of working out, you can technically just put the equation into the graphing feature of your calculator, and then you can use your graphics calculator to not only actually graph a function in general, but also to find the x-intercepts. That's it for this video, guys. Thank you for watching.